Hello and welcome to the GCSE Chemistry tutorial for topic C4, Chemical Changes. This tutorial covers reactions of metals, the reactivity series, reactions of metals with water and acids, oxidation and reduction, displacement and the extraction of metals. Starting off with, you need to know the list of metals in order of reactivity. It's called the reactivity series. At the top you have the most reactive metals, at the bottom you have the least. The more reactive the metal is, the more easily it will lose electrons to form positive ions. And the more reactive it is, the more violently it will react with water and oxygen and acid. Carbon and hydrogen are in this list, but they're not metals. The reason they're in the list is to be able to compare the reactivity of them compared to metals. In general, when you react acids, the salt that you make depends on the acid that you started with. If you use hydrochloric acid, the salt ends in the word chloride. If you use sulfuric acid, the salt ends in the word sulfate. And if you use nitric acid, the salt ends in the word nitrate. Let's look at some examples of these. When you react a metal with acid, you make a salt and hydrogen comes off as bubbles and you can see the gas being formed. Now you can't just say salt, you need to say what salt is made. So that depends on the acid. If it's magnesium and hydrochloric acid, the salt would be magnesium chloride. And there's a balanced equation there as well. Metals with oxides make a salt and water. Some examples below with balanced equations. Metals with carbonates make a salt, water and carbon dioxide. Look at the example below. Calcium carbonate plus hydrochloric acid makes the salt calcium chloride. It also makes water and carbon dioxide. Metals with water. Not all metals react with water, but alkali metals do, as we've mentioned before in the periodic table tutorial. They make a metal hydroxide and hydrogen. Many metals are found combined with oxygen in rocks called ores. And ores contain metal and oxygen and other elements, and we'll need to learn about how we can extract a metal from its ore. To understand that, you need to know what two words mean. Oxidation means gaining oxygen or losing electrons. The example there of magnesium gaining oxygen. Reduction means removing oxygen or gaining of electrons. And reduction can be used to get metals from their ores or to extract metals from their ores. Look at the example below. Copper oxide is an ore of copper. If you heat it with carbon, you are left with copper on its own and carbon dioxide. So that is called carbon reduction because the carbon is used to reduce the copper oxide. Redox reactions occur when both reduction and oxidation occur at the same time. The example again below, copper is reduced because it loses oxygen and carbon is oxidized because it gains oxygen. Displacement reactions are when a more reactive metal takes the place of a less reactive metal. So you need to know the list of metals in the reactivity series for this. Look at this example. If you put magnesium into some copper sulfate, because magnesium is more reactive than copper, there is a displacement reaction. What happens is magnesium takes the place of copper and forms magnesium sulfate and then leaves copper behind, which forms like a residue on top of the piece of magnesium, turning it brown. In this reaction, there is still oxidation and reduction. There is oxidation because the metals lose electrons and reduction because the metal ions gain electrons. Displacement reactions also happen with halogens. Remember, these are group 7 in the periodic table. Chlorine and potassium bromide, because chlorine is more reactive than bromine, it will displace it. This is also an example of a redox reaction because there is reduction, because chlorine atoms gain electrons to become chloride ions. And there is oxidation because bromide ions lose electrons to become bromine atoms. Now, How a metal is extracted from its ore is determined by where it is in the reactivity series. If a metal is below carbon, it can be extracted from its ore using carbon. For example, zinc oxide is an ore of zinc. If you heat it with carbon, you have zinc plus carbon dioxide. However, for the elements above carbon, you can't use carbon to extract them from their ore because carbon is less reactive than them. So instead, another method is used called electrolysis. Metals at the bottom, like gold and silver, they're really unreactive. They're so unreactive they don't actually come found in ores. They're native and so they're found uncombined, so you don't have to extract them from their ore. So what actually is electrolysis? We'll be looking at it again in another tutorial, but it's using electricity to break down a compound, in this case to break down an ore to get its metal. It's quite expensive and requires a lot of energy, and on a large scale it can be done to extract aluminium from its ore. Aluminium ore is called bauxite or aluminium oxide. What you would do is you would heat it and mix it with something called molten cryolite, and that lowers the melting point. Once it's a liquid or molten, you put electricity through it using electrodes. So you'd have positive and a negative electrodes. The ions in the compound, the positive ions, will be attracted to the negative electrode and they gain electrons to turn into aluminium and form at the bottom of the tank. The negative oxygen ions are attracted to the positive electrode and they lose electrons to form oxygen gas. In summary, you're breaking down aluminium oxide to make aluminium and oxygen. If you pause the tutorial and try and answer these questions now. So what's a reactivity series? It's a list of metals in order of reactivity. You do actually need to know the list in order, so look back at the slides and make sure you know that list. What is a redox reaction? That's where reduction and oxidation occurs. Reduction is the gain of electrons or the loss of oxygen, and oxidation is the loss of electrons or the gain of oxygen. A way to remember that is oil rig. Oxidation is loss of electrons, reduction is gain of electrons. How is iron extracted from its ore and why? Well, you would use carbon. And that's because iron is less reactive than carbon, so it can be extracted from its ore using carbon. Number 4, how is aluminium extracted from its ore? Well, you couldn't use carbon because aluminium is more reactive than carbon, so you would have to use electrolysis. In summary, we've looked at the reactivity series, the reactions of metals, oxidation and reduction, displacement reactions, and extraction of metals.